discussing BARS 2023. This is a Bay Area Robotics Symposium organized by Berkeley and Stanford. This is the first time I attended it, so I don't know the exact distribution of who organizes what. My impression is that this was an unbelievably interesting event, and the reason it's one thing I'm pretty interested in this sector, but I think we're also at the cusp of massive developments here, and this comes across when you talk to people, when you see what they're doing. In general, I would say there's a big picture, three developments that are interesting. One is the emergence of large language models, which can be leveraged for robotics in two specific ways. One is semantics, and the other is you can actually try to use sensory data and do the same tokenized and masked learning like you do with language. I would say in context with that, simulation is becoming more and more important for several applications. I'm going to go into details. I think also what's really important is nerves and occupancy networks. So that solves for depth, and because of that, you have basically you can spare yourself the LiDAR and the radar, something that Tesla has been doing for a while now. So I think this was the biggest insight from my perspective as far as Tesla is concerned, that their bet on cameras actually is working out. And that's partly because nerves have really solved the depth issue, probably in a computationally less challenging manner than what they were doing before. So again, I think nerves occupancy solves for depth, enables navigation through vision, LLMs combining with robotics, and then we have simulation really playing a big role. I'm going to go into the details, but those are the big takeaways. This is not even wrong podcast. It's November 1st, 2023. This is Scrim Telco. Since the last update, we're down 0.5%. The market's up 2.5%. For the year, we're up 76.9%. The market's up 10%. We're outperforming by 66.9%. So the BARS 2023 Robotics Symposium took place at Stanford, and I was lucky to participate. And I think given all the buzz that's going on with AI, I think people are even now, I would say people are underestimating the massive, massive potential that is coming, because we are solving for things that even 2-3 years ago seemed to be almost impossible. High dexterity solutions for robotics, for example. We have vision now almost exclusively able to navigate through all kinds of environments because of nerves. We have multi-agent modeling and decision making being solved in part thanks to advances in reinforcement learning, and also a bunch of other technologies which are attached to this. And I think some of the things that I wasn't aware of is the multi-sensory input that robots now have taking advantage of. One is touch, and then there's also the augmented vision through context, which is part of the large language models context also within robotics. So let's now go through the, I'm going to go from professor to professor, sorted by theme. So what I mean with that is I'm going to start with Jitendra Malik, and I'm just going to use their last names. I don't want to get hogged down with names. So Malik presents a paper where he shows very high dexterity abilities, and he's doing that with simulation. I think this is the main. I spoke with Malik after his presentation. I asked him, look, are we playing in the wrong sandbox here? Shouldn't we be focusing fully on simulation instead of doing the hardcore robotics, and shouldn't we get our models pre-trained? And he said yes, but he kind of gave me a bit of a, I would say almost fluffy answer, like he said, well, yeah, but not everybody believes in that. And I believe that, either he's old and he just doesn't want to try something new, or he's getting a lot of pushback from the community. But yeah, I didn't like that particular answer, but nevertheless, Malik is Malik. He's a legend in the field. I think one of the really interesting applications and papers that he presented, or I'm not sure if he presented it here, but it's definitely in the archive, and it's one of the more recent papers, is where they tokenize sensory data, such as, for example, the motion of a robot, or the tactile information of a robot, and they tokenize that, and they learn it in a sort of mask model, like a language model. And I think this is really, really interesting. Levin does the same thing. Dries from TU also has a paper out where he is being cited quite a bit. So maybe he was the first doing that with vision. Bog is actually offering a tokenized repository for that kind of data. So I really think this is Abil's working on that. So I think this idea that you can use large language model architecture and transfer it to multi-sensory data and robots is really, really massive. And I'm going to keep digging on this. So definitely. Then we have context learning. So we use the large language model technology, not just for tokenizing sensory data, but also for context. We have, let's say, Finn's working on that. Hausmann works on that. He collaborates with Finn. Song has a paper out. So what we're talking about here is really understand what is in the picture, and where is it, and why is it there, and what's the context. All of these things can be leveraged with large language models, because we have that ability. We have the summary technology now that allows us to very quickly, in a one-shot way or few-shot way, understand the scene, organize the scene. This is another big theme that came across. We can help robots navigate an environment by telling them, look, this is the room. Over there, that's the drawers. Here is the carpet. You don't want to put things on the carpet. You put them in the drawer. You can navigate the robot. Now, I would say this is almost like a hybrid, the middle step towards what Levin and Abil and Malik and others are doing, which is just tokenize the motion, tokenize let's say if you have 6 degrees of freedom, right? You have X, Y, Z axis and the rotation around that axis. Why don't you tokenize all that? Why don't you add some physics to it, tokenize everything, and learn through mask? Now, this is much, much easier said than done, because you don't have that much data. We don't have these trillions of words that the internet offers with large language models. But we can start, and Bog is offering a repository for that. Finn is working on that too. So I think those are definitely interesting. Those are interesting developments in the robotics space. Another theme was tactile sensing, multi-sensory sensing in general, but tactile sensing and soft robotics. Kennedy, Tomizuka, Zhao, and Okamura talked about that. Okamura has a special application where she's using sensing technology, touch technology, for remote robotic surgery, where the operator can feel the skin and the sort of resistance of the patient while operating. So this is very interesting. I came across the same theme in my chemical engineering seminar, where the lady that presented there spoke about sort of soft liquids, touch sensitive liquids. This is in line with that. Kennedy's working on this. Again, Tomizuka, soft robotics actuated with pneumatics. What you have here is also sort of an engineering problem, mechanical engineering problem. It's nice to see how mechanical engineers have their niche here, because you have, let's say, in soft robotics, you really have this mechanical problem. How does this thing move? And soft robotics can be used in several applications that maybe hard robotics or hard arm robotics are more dangerous. I could see soft robotics being applied to, let's say, factory work. Soft just means it's not a rigid arm, but then you have mechanical optimization type problems where, because this thing has a lot more degrees of freedom in terms of moving, you have to solve for that. Next, I think a next field is sort of multi-agent, multi-agent behavior. There's a couple of presentations. I'm just naming two, Bayan and Muller. So Bayan does multi-agent behavior model based on experimental and sort of conceptual concepts. Experimental means he actually has trucks, delivery trucks that are autonomous. The idea here is that you have these rational agents that are moving around in the wild, and they're going to act in a certain way. There's game theory here. There's almost chess playing. There's a lot of interesting learnings, I think, that we can get from these rational agents, because these agents are truly rational. That is the unique thing here, and I think it's something particularly economics people should definitely be happy to hear, that this is possible now with these rational agents. We're in early days here. Something that I've seen also develop, let's say, with in the aerospace sort of community, people are looking at how autonomous flight vehicles behave. Actually, Kochendorfer is working on this, is aerospace engineer. He actually presented a different paper, which is occupancy networks in 4D. So this is another field, actually, I want to just mention, because this is really, really important. This goes back to also Tesla and the occupancy network usage within vision. So you have 3D, so you have depth. How about 4D? How about you have the evolution of pixels within occupancy networks? This is Kochendorfer offers sort of a video prediction technology solution here, where he takes occupancy, he cells within occupancy networks, and then predicts the evolution of cells. I think, again, something incredibly applicable to Tesla and the self-driving solution. So to summarize, BARS 2023 was a huge success for me. I had the chance to talk to people like Malik and others. I had the chance to talk to also companies like Gatik and Wave, actually. I haven't even mentioned that, but Wave, for example, is a sort of end-to-end company that does end-to-end learning, and I've learned really that they're not really doing end-to-end learning. This is very much segmented still into different tasks, and that the end-to-end learning is not really happening. So, and also that they have operators, which is interesting. Which this is really just more of a side note, but you can see how people are, on the one hand, marketing themselves in one way, but then when it comes to engineering and really when the rubber meets the road, when you talk to engineers about how they're actually doing their work, you realize that there is definitely not everything is as rosy, and I assume that also applies to Tesla. But nevertheless, I met Gatik, I met Waves. There was also a company, Johnson & Johnson was there with their robotics, surgery robotics. I didn't talk to them, and then Waymo was there. I also didn't talk to them. But let's focus again on the people that I actually was really happy to talk to, in particularly Malik. Malik spoke about simulation. Simulation is the future of robotics, even though right now it's still in early days. He mentioned Isaac, the Omniverse by NVIDIA, which is probably going to be the killer app for that, and that's also what Jensen Huang said. So this robotics space is incredibly dynamic. It's moving. We have the application of large language models, in particular for the tokenization of sensory data, which is amazing, but also for contextual data. We have tactile sensing and other, but in particularly tactile, which is very interesting. We have multi-agent behavior, and then we have also occupancy network development, sort of dynamic 4D occupancy network, which solves the vision problem even further and really makes cameras the ultimate sensor for dynamic robotics. Thank you.